Thank you for having me. It's a pleasure to be here. I'm Sanmi Koyejo, faculty in Stanford Computer Science. I'm going to talk a bit about some work that we've been doing on a book on machine learning from human preferences. This is work with Sang Trong, who's over there somewhere, and Andy Haupt, who's over here, who do all the actual work, and I get to come say nice things here like I did anything. But anyways, it's a fun little collaborative project. And so maybe to set things up, there's a website, feel free to take a look. I forgot that we had put this tab here, but as Michael alluded to, we're one of those who graciously borrowed his nice template, found it very productive. We added slides. I don't know if you had slides, so we innovated a little bit. Yeah, so if you go to the website, the slides we use for the course, you can actually see, and these are being updated. So thinking about this as pedagogical material that people can use and sort of easily engage with. So why did we do this? So, okay, maybe a bit more on the mechanism. So additional things that we think are interesting and I think meaningfully enabled by the platform is easy incorporation of examples, easy incorporation of code. So again, if you get a chance to look at the book, you'll see a bunch of these examples that make it easy for students to play with aspects of the topic. I'll say a bit more about topic in a second. So just a combination of, again, the conceptual material, a little bit of math, but also practical examples. And we found that very productive for engaging with students. Okay, so I don't know why, or I don't know if you've heard, but AI is all the rage now, and arguably, at least in sort of to some extent technical, but also public perception, a lot of why AI really captured, particularly ChatGPT, captured the public imagination was sort of how well it engaged in ways people expected conversations to engage. And so this went from, maybe even a year before this, language models that were arguably comparable. These were, again, tools that were good at spitting out text, but they would create text that, you'd ask a question, what is the weather like today? And it would continue with, the weather is a meaningful construct because it says something about temperature. It goes off in arbitrary directions and it's hard to tune and align. And some of what changed on the technical front is very focused work in going from sort of just being able to spit out text at the time to being able to respond and engage with people, and also specifically sort of align with some notion of human preference. And so part of the technology that got this to work were things that can be explained in this way. So roughly, you take examples from models and sort of other sources, you show it to people, you get people to tell you which they prefer in various ways, and you try to put these kind of information back in the model so that it gets better at responding in ways that humans like. And so this is some of the key technology that got some of these kinds of ideas, or at least ChatGPT again, to get really exciting and led to some of the excitement about and tons of investment in AI. Behind the scenes, a lot of these ideas borrow from early ideas. So there's work in recommendation systems, there's work in cognitive science, there's work across a variety of different disciplines. They've thought about what human choice is, what human preferences are. And so some of the gap that we saw was there wasn't really a great place to sort of get all this information synthesized. There are a few snippets of things out there. Companies that notoriously, well, some of these things were published, but they're not great at publishing a lot of what they're doing. And so we saw an opportunity to sort of think through a formal material that allows people to learn how to think about learning from human preferences and human choices. And so we wrote this textbook as a way to engage with this subject. This textbook was written at the same time as when we started a class. And so we've had this class now over couple of different years. So it's it's early. It's only been a couple of years, but couple hundred students have gone through the class, and we're sort of continuing to update and improve the material. So the book, as mentioned, there's a class at the bottom there. A couple of iterations now. The book is, to our knowledge, the first graduate level textbook on learning from human feedback, and particularly with this focus on sort of modern AI use cases. Very intentionally, it's designed to be multidisciplinary. And so it covers ideas that come from machine learning, but also ideas within machine learning. We have this great history of rediscovering things every few years. And so there's work I mentioned briefly, but things like recommendation systems, where some of these ideas had been out before and reinvented again. So we cover some of that material. We cover relevant material from, again, some of the material from psychology, some material from other disciplines. We try to be hands-on. So as mentioned, and you saw briefly in the example, there's interactive code, there's lots of examples, annotated case studies, so hopefully make it easy for students to engage with the material very directly. So as mentioned, we've had a chance to test some of this out in the class, mostly the positive signal. So again, improving. This is the point of these kinds of living textbook ideas, is we get a chance to keep engaging and improving it over time. And we've had students from a variety of different disciplines. So part of it is the excitement of the topic, but I think part of it also is, we think anyway, is the way we engage in the material, and again, pull from lots of different disciplines. So we have both advisors, but also students from all the way from computer science all the way to areas like law, thinking about these kinds of questions. And easily you can imagine there are lots of, I think, fascinating questions that show up when you ask about what it means to learn from human preferences at the scale of modern AI and machine learning, generative AI models. So again, to our knowledge, we're the first course on this topic. We're slowly starting to get folks around the world engaging with this material in a formal way. There are, again, a few blog posts and things out there, but first, again, try to bring this together formally in a way that people can engage and use. And it's open, so again, you can go up there, you can take a look. Okay, I'll say more about this later, but we allow, or at least our vision is to enable this access to some of the cutting edge in deployments of AI in the field. We have built the material to be easy to reuse, remix, critique, and all the other ways that both instructors and students might want to engage in material. We want to make it easy, again, to equip learners to shape the AI systems that shape them in the ways that make sense in their particular context. So, some of the things that you might find when you take a look. So part of what we're trying to teach is thinking about sort of choice, and so we have choice examples. You can take a real demo within the book and agree or disagree with a variety of different options. From this, again, sort of get a sense of how the models under the hood work for learning from your preferences, and how this might work across multiple people's preferences. Some code examples, as mentioned briefly at the beginning, so again, allows you to engage with what it means to build software that implements some of what you might be learning on the technical side. And visualizations that allow you to, again, easily engage with the material. Okay, so, feel free to, again, the advertising here, take a look. You're welcome to tell us everything we did right. You can also tell us some things we did wrong. But, start a pull request, open an issue. But, everything's online and easy to engage with. And I think that's it. Take a couple of questions.
All right, we've got some time for questions. Maybe I will start with one, which is whether you've leveraged open source language models at all for like your exercises or the things you do in the book.
Yeah, so we've played with a little bit. So yes, for getting most of the interesting things at scale, we need reasonable size, reasonable complexity models, and we often would use open source models. So things out of Meta, I think most often, but other tools can be reasonable. You can get a fair way by really, really small models that you can build from scratch, at least for the conceptual understanding. If you want the cool demos, you probably want.
Can people do interesting stuff like using models that I could run on my laptop, or do you have to go to the next level of compute?
I think you can start to see interesting stuff from laptop level models. So these would be 8 billion size Llama models. I think enough to at least see how your preference might fine tune the model behavior and sort of align a little bit. You feel like, okay, go ahead.
Add to that Sang amazingly, he puts in all these code examples, and for one very prominent preference fine-tuning algorithm, there is a completely NumPy-based matrix version of the thing, which is then not a language model because most of these don't run, but runs in the browser for the book. And I think a lot of the approach of the small coding examples is that it's completely set up for you. Because oftentimes we just need a GPU somewhere.
Right.
And many people don't have that.
Right.
Yeah.
Cool.
Sang is here. Was that a good enough summary of? I don't know if you heard it. I don't know. Other nice things that people seem to like are one of our first homeworks. You code one of the very popular human feedback models, which people read, and actually is often the motivation for taking the class anyway, and sort of show up in the first homework. People really seem to get a kick out of it in a way that I had not anticipated at all, actually. Cool. So that's a fun one. But yeah, you can play with some interesting models. So if there are no other questions, I think given that our break last time got shortened, we will take a short break now, come back at 3:45 when we're supposed to start the next talk? Yeah, 3:45. We'll pick it up then. Thanks again, Sammy.